I'm excited to speak today. I was kind of checking in this morning and I was like, I'm feeling a little nervous about this presentation. And I was like, why am I nervous? This is my lane. I know my stuff. And I think it was all the talk yesterday about AI and some terminology that I'm not familiar with. And I'm intimidated. I'm intimidated by that. And, but that's the beauty of our relationship with Remsoft. And they've always been a leader for us in the technology space and kind of like blazing ahead and exploring n- new concepts that take us a little bit longer to adopt. Um, and so that's great. That's where we need to be and where they need to be. It's been a great partnership. Let's see if I can. Big green button. There we go. So I'm going to give us a little bit of background. You heard from Stephen Edens yesterday about AFM and our use of Inflor. I'll give a little more background and context about AFM. Um, just to kind of frame the problem so you can understand what we do as a resource planning group at AFM. Um, and then I'll talk a little bit. I've got just kind of a case study, a small property that we modeled recently, where we did some kind of new and different things. And I'll kind of walk you through that. But AFM, we're a forestry consulting firm. We don't own land, we manage land for variety of clients. So we have like a large land management group. We have over 200 foresters on staff in different regions across the US and Central America. We also have a real estate brokerage firm. And then we also have our forest technology services. So we kind of see those three businesses across the company. We're celebrating our 60th anniversary this year, which is big. Um, I've been around for 20 plus of those years, which is kind of crazy. But yeah, we've kind of slowly grown geographically over the years at a slow, comfortable pace. Um, Here's a map. I love maps, but that shows. I think Stephen threw this one up yesterday, but it just shows where we have boots on the ground, where we manage land on the ground. And so our resource planning team is responsible for the harvest scheduling, valuation, discounted cash flow, strategic planning, all the things in all these regions. So we work with our land managers and our clients in all these regions to provide harvest planning services. um, just a little background on our clients because it is such a diverse group of clients. We have smaller private landowners that we manage for, it may be a few hundred, several thousand acres, all the way up to the large investment management firms where we're managing a 1 million acre asset or more. Um, we do a, we do have some public contracts, um, just small family offices, some Native American tribes, and just a full range of clients with different objectives that we service. Um, I wanted to share kind of, so you can see the breadth of what we do. We kind of took a look back at the models that we run over the last 7 years. Um, and I encourage you, my team is here, Wesley, Johnson, and Daniel and Justin. If you haven't met them and talked to them, they'd be happy to tell you all about what we do. Um, but Wesley manages our harvest planning group, and um, we love data. So we took all the data from all the models that we run, so we could kind of look back over the years and see. But we run Woodstock models on around 100 different assets each year. It may not be the same assets every year, um, and on around 4 or 5 million acres. I don't know the hectares on that one. Um, and then we also run models for different purposes. They're all discounted cash flow models. We're always optimizing the net present value of timber operations. there's a lot of different factors that play into that objective function. But that's kind of the premise of what we're doing. But sometimes that's for more valuation and income approach to value on timberland. Sometimes the focus is more management planning and focused on tactical planning or budgeting. Um, and as of late, we've done some carbon modeling where that was the premise. Again, solving for net present value, but the focus has been more on carbon and additionality and those things. And we also support our appraisal group and help them with their income approach to value. And this is just to see kind of where we're running those models. A little map here. And we operate across all these different regions. And over the years, we have developed template models in Woodstock so that we can more or less, it never is plug and play exactly because each model has little nuances. But we understand the variables that need to go into each one of these models, each one of these regions, and what the drivers are. So we've tried to make it as plug and play as possible across all these regions in our template models. And I thought we'd go back 20 plus years of our relationship and kind of the evolution of the tools that we use with Remsoft. And we got our first Woodstock license, I believe, back in 2002. I wasn't around then. We had our first Woodstock Mosaic license. We had some in-house simulator software we were using that was DOS based, and um, we needed something better that could move us forward and help us service our clients. And then fast forward it took us several years to adopt Woodstock, um, but we had developed DLLs, which were equations that were embedded, and we would call the DLLs to manage our growth and yield in the models. Um, we finally launched that in 2006, and that was big. That pushed us forward in the growth and yield space and modeling. It allowed us to be really flexible and model a lot of different situations and quickly. And then 2009, we started using Publisher. Remsoft came out with a way to publish a model so that it could be used in other um, end user tools. And we worked with them on some of those concepts back in the day. But Publisher is what allowed us to begin to use Remsoft Analyst for Excel. Fast forward there to 2014. So we spend a lot of time in Analyst for Excel because we publish the models, push them into Excel, and that's the world that we kind of live in for um, presenting results to all the stakeholders and our clients and others and foresters. Um, and now, yeah, and then in 2016, we started using Integrator pretty heavily. That allowed us to integrate large data sets, large yield sets into some pretty big models that we had. Um, and then in 2019, uh, that was when we partnered and launched the Infloor solution. So that was a big way to integrate our solutions together and getting standardized data that we could script very easily out of our data management system and push through into models. 2020, we built our first AO model. 2022, we really started using the template file and integrate. Before we were using Integrator just to integrate large yield sets, but we really started using the power of Integrator to integrate more sections of our model in that template file. So that was big. That was still 4 years ago. We've done a lot in the last 4 years too. I think the last 4 years have just been more about efficiencies and really perfecting a lot of those template models and just the workflows. But we have 10 plus analysts and appraisers at AFM that use Woodstock. So we have kind of our own user group in-house, which is really nice to have the support and so many users. This diagram kind of shows the mechanics of how that workflow happens at AFM. There's three main components that go into our Woodstock model, and that's our inventory um, and spatial data, the static data that we would check out of Infloor, or that we would get from any other FMS or source data. That's your stand level data. And then we generate yield tables for that data. And then we also have to have all the input assumptions, all your financial assumptions, market assumptions, and those things. Really, the middle piece there, the yield sets, is where we have three biometricians on staff, and we've spent a lot of time developing the growth and yield that goes into our models. And as of late, we also that same growth and yield methodology and scripting that goes into our Woodstock models is also um, in the Infloor system that runs the data updates and the growth projections in Infloor. So we can finally bring all that together and get the same answer in both of those spaces on the data management side and on the longer term projection side. But all those pieces flow into our Woodstock models, no, regardless of the region that we're in. These are all stand level models, and they're all annual planning periods. We typically run a 50-year model, um, and that flows into our long-term management plans, but also our near-term budgets and tactical planning. Um, so that's kind of the mechanics of the pieces that have to go into the model. Now, the people around making the modeling happen. Of course, I've got the planning analyst as the center of the universe there. um, but we work with the data manager, we work with the client, the whatever the customer, the asset manager, the landowner. We definitely work with our foresters, um, and then we also are back and forth working with our biometricians, our inventory analysts, um, and there's always several iterations and a lot of conversations to get all those stakeholders on board because everybody kind of has their own objectives and initiatives and that. Um, and this, I tried to make a messy slide here, but the idea was we have so many different objectives and initiatives across all these different types of clients, trying to do different stakeholders, trying to do different things with the model. But we have one model, and sometimes it's like we just need allowable harvest, or we are doing stand level budgeting, but we need to know the longer term pro forma and what that looks like. Sometimes they're trying to answer questions, just we're renegotiating a supply agreement, or we're trying to figure out the silviculture we should use in these depressed markets. Do we plant less trees? Do we thin later, earlier? Not at all. Um, so there's all these objectives that people want to get out of the models. Um, and Woodstock has always allowed us to do that. In one single model, we can solve all these problems and bring it all together. Um, and that's the beauty of Woodstock and what it does for us and our business. Um, so thinking ahead, we've seen a lot of changes, and we've talked a lot about that at this conference. Like, we're moving fast, and technology is moving quick, and markets are changing. A lot of changes and kind of new challenges for us in our modeling. And I kind of see that there's like three big things that are changing, and one is increased data precision. Um, we have more data than we've ever had. It's changing faster. It's great that it's so dynamic, but it changes every day. And we're utilizing a lot higher precision data, um, and it just increases the complexity of our modeling. Um, and it's a lot more precise. Like, we're looking at individual tree data and in-stand variability, and so just the precision of the data has increased. And like I was saying about those different objectives, there's just more stakeholders involved, more people interested in our story. We have some um, newer customers that have a different perspective and um, different objectives that they bring to the table. A lot of that's European investment. Um, they just have more focus on environmental goals and sustainability, climate change mitigation, and those kinds of things. And this just makes for more complex problems that we have to solve, more regulations, um, more market changes, that kind of thing. So I thought I would kind of go through a case study um, of one of these 100 models that we've run, um, just to kind of give you an idea of what those questions that we're getting and the problems that we're solving. So this was a 12,000 acre property across 2 states. It was a newer client of ours, their first U.S. investment. Um, they're also a client. We're managing the land, also managing the data in Inflor. So it was new onboarding them into AFM and all of our systems. Um, it's a property that was historically managed for investment timber land. Um, but some of the unique challenges were the data wasn't perfect. It never is, but there were some gaps in the data and understanding what was available for harvest, what species were out there, um, the inventory, and that kind of thing. They also had certification requirements, which is not uncommon, but there were several different certification programs, and there were some conflicting objectives there. And it's just it's a very small property to be so geographically dispersed. I'll show you a map here. And they also had some special reporting requirements that we hadn't dealt with before, along the lines of carbon and special conservation areas they wanted to see certain reports for. So yeah, just a kind of a shotgun spread out property in very different market areas. Um, so, and then the just typical challenges that we face with every model. Um, Again, I kind of talked about like if we're looking at a long-term plan, but we're also planning for next year and putting a budget together and looking at that tactical um, time period, all in the same model. Um, and it was also an opportunity for us to look at the data because you don't really know how good the data is until you use it for something. So, um, putting it into the harvest schedule and using it to help inform decisions um, helps you kind of refine the data and look at it a little finer resolution. Um, and some of the data gaps were just we didn't know what was operable for harvest. Um, it would take a forester to go out there and look at a particular area and decide whether we could operate in that area or not. Um, and some of the species typing was not perfect. So we worked with the foresters quite a bit to get that data squared away. And then the constraints were pretty typical, just near-term constraints on specific stands that needed to be harvested, specific species that needed to be planted, and then our operational constraints. What could we move? We wanted to make sure there were no big fluctuations in harvests across the horizon. Um, and this is kind of the graphic that I showed earlier with the different stakeholders, but specifically, supposed to be a Remsoft logo there. Um, but again, the planning analyst sits in the middle, and we interface with all the different stakeholders. We're kind of like the mediary between different objectives, and some folks are looking longer term, and some folks are more like, I need to know what to do next month. And those objectives can conflict. Um, so we worked with the Stevens team and the, the data manager to kind of perfect some of those holes in the data. And we had to go back to the forester and go back to our mapping and our wildlife biologist and our certification manager and get those areas kind of all mapped out and into the in-floor system, which took a little bit of development identifying what those areas were, um, and signifying how they could be managed in the future or if there are restrictions on them. Um, so that exercise happened and involved everybody. And then our biometricians, inventory analysts were involved, and that we had to generate the yield sets more than once, with different product specifications and different units of measure. So there was work with the biometricians. And then on the client side, the investment manager or the portfolio manager was interested in, the longer term performa. I've got to share this with my investors. I've got to tell the story. And then there were also kind of a sustainability team, and they had different objectives. They were more concerned with carbon and um, biodiversity and modeling some different management objectives into the model that we could show the impact of those things. Um, so we're the happy middleman that keeps all of those objectives together. So at the end of the day, we modeled two distinct market zones. We in the South, most of the time we are modeling stumpage markets. So we're not modeling the harvesting and production costs, because the landowner gets the net revenue um, from the harvest. So that's our revenue driver in the model is our stumpage prices. So there were two different distinct zones there with different pricing and different markets. And we worked with the field guys to update the data. We modeled some longleaf pine restoration areas, which was a little different than our typical species that we model. So the biometricians had to get involved there. And then I said we had a distinct set of yields that fed downstream workflows that fed carbon models. So we took Woodstock and we ran the optimization. And then after we got the results, we went back into the model and plugged in a new set of yields with different product specifications that were cubic meters per hectare instead of tons per acre. So a different yield set. And then we just used Woodstock to play back the schedule the optimal schedule. We played it back with a different set of yields. And then we were able to feed those other reporting and downstream workflows and get the client what they needed there. Um, so that was definitely unique, but Woodstock allowed us to do that. And then the other big result was that, and this is typical for all of our plans, but these are stand level plans, 50 years, because we're looking at discounted cash flow. Um, so we're looking over that 50-year horizon. We're looking at that pro forma over the long term, which is your strategic plan. But we also are using that for our tactical planning and our budgeting for next year or the next 3 to 5 years. And we look at that spatially, and where we're going to go on the ground. And the decisions that we make in the near term, in the first 3 years, could impact the next rotation or the timing of harvest in the next rotation. Um, so that's one thing that may be a little unique is that our strategic plans and our tactical plans are all in the same lovely model. Um, some next steps to enhance our planning. Um, we did not really use Spatial Optimizer, and this is an annual process that we do for this client. So next year the data will be more refined, and we'll use Spatial Optimizer to kind of get a better spatial plan on the ground. Um, and then we also will have, I'm sure we will have more alternative management strategies that the client is trying. So we'll do that in the next round. Maybe lower density plantations, maybe more of those longleaf conversion areas. And there were some special conservation areas that we need to address that we'll manage differently in the model with different regimes. And there may be some restricted areas due to that conservation value as well. And then we'll have updated data from InFlora, just plug and play. We'll export the data from InFlora and push it through our routines into Woodstock again for an update. And then also exciting for next year, we will, and then Stephen talked about this a little bit, but we're developing a budgeting tool in InFlora that will integrate into Woodstock so that there's a workflow that will get information out of InFlora about planned harvests that will flow into Woodstock. And then we'll also, the other way, have information that results out of Woodstock that can flow into InFlora and write those budgets. So that's exciting. Next step. And so just, yeah, looking ahead, kind of to reiterate what I said about modeling in the future and what's coming our way is definitely this increased data precision and the speed at which we need to be able to model new problems and new data and more precise data. I think we're on top of that. We're heading in that direction. And it's exciting to see all that happening. There is also a lot of attention to, this came up a little bit yesterday, to non-timber income. You know, our models used to be just straight timber cash flows. And anything else you were generating on the property might have just been extra for you. But we're incorporating more and more of those non-timber income streams into the model. And it matters if you're taking a stand out of timber to put it into solar or whatever that other income stream may be. We model for that so you know the impact. Um, but there's more and more attention to those other values and ecosystem services, um, carbon, other values that change the timber management and that add value, add total value to the NPV. And I think another thing that as I look ahead, I think about what our foresters are doing, and we've always been managing sustainably, um, responsibly. It's what we do as foresters. Like we were the first environmentalists. But I think it's just being able to tell our story. We're collecting all the data. We have all the information. We're managing sustainably as we always have. It's just being able to tell that story and report it. There's more reporting, um, and there's more questions around it and how we get that information out and kind of tell the story. So that's how we kind of integrate our data and systems all together and help our clients make better decisions. Are there any questions?
Have a mic here if you need to speak up. Thank you very much, Laura. That was an excellent presentation. It's fine.
Hello, my name is Louis, and working at the chef forester in Quebec. So English is not my first language, so I will try to ask you a question. You, you, wait a minute. In the second or third slide, you talk about large yield to use integrator. So I would like to have a definition of a large yield.
Oh,
Is
I,
it too technical or
no,
no?
I've got the team here too. I don't know if I can talk if I know file sizes. Um, but in that particular, the one I was thinking of in that particular case, it was a LiDAR derived inventory. It was a stand level inventory in the lake states. So uneven aged hardwood management. Very difficult to even define stands, but we had harvest blocks, stands of timber. Um, but it was about 600,000 acres. Um, and we had 50,000 development types in that model. And each development type had a stand table and also had a um, a potential harvest regimes and then their post-harvest condition tables. So I don't know the number of tables. We had for each loops that we just named, we just bin the data and 1 through 40 and just looped in to integrate the YLD files into, um, so we could just include .yld files for all of the stands. Um, yeah, I'm not sure the amount of data, but it was big and we made it efficient.
Okay, just to tag on to that.
Yeah.
So Wesley Johnson, also with AFM. You can run a Woodstock model with one yield table, right? If you just cycle one stand back to the same table. But we love to use our biometricians to their full extent. And so we'll take every single stand or every single strata and run that stand or strata through a lot of different silvicultural regimes. And so our yield sets can be tens of thousands, maybe close to 1 million yield tables that we're all going to integrate into our models if if necessary. And so the specific one that Laura's referencing was like the biggest, one of the biggest still, but like the first really, really big one that we tried to do that with. And that was a really big deal for us to figure out how to bring it all into Woodstock and have Woodstock solve and it not run for days and days and days. So I hope that helps.
I've got a question about the DLLs. I remember hearing about them a long time ago and never actually taken the step of developing a DLL to run. So I guess I have a general question for Remsoft and you is, do those still work? Are you still using them? And what what types of growth and yield models have you successfully transitioned into DLLs? And for context, is like I work with FVS and FPS. So these are kind of single tree models. Where you can't just put relatively simple set of parameters in to get a yield curve. And so I was just wondering what the current state
Sure.
DLLs was.
Yeah, well, the DLLs that we programmed were for pine plantation, so stand level models where you need stand level stocking metrics, age, site index, trees per acre, basal area. Those are the parameters you plug in, and these were equations published by the co-op, the popular co-ops in the southeast. Um, they were very flexible, worked very well. But we have moved beyond that. And I know that Woodstock Next Gen, I don't want to speak for, you can speak to Marie and that whole session, but their Remsoft is moving away from the DLLs. And so I think in Next Gen, the DLLs will not perform. It's not an option. We've talked about other options to connect to um, other platforms or potentially R. We do a lot in R. A lot of our processing and scripting packages happen in R. But I think that's going away. But it was good while it lasted and it served us well. But now we're using stand table projection because we do have diameter class data on most of our properties and want to be able to utilize that. So we're doing stand table projection and developing actual yield tables. And one thing about the DLLs, they were a little bit of a black box. You never could see like a full age dependent yield table. You just saw the parameters that were passed back. So I think it's a thing of the past.
Thank you, Laura. Are there any remaining questions? We have time for one more. Oh, thank you. getting my steps in for today.
Hey, Laura. Ricardo Baez from Gamble Global. Um, with such diversity of clients and projects and products and services, how do you deal with the data integrity issue? Can you
I'm sorry, the data.
integrity, the quality of the data sets, integrity?
Oh, yeah. Um, somebody said garbage in, garbage out yesterday. But we're careful about, we are a consultant. We don't want to say, no, we're not going to do that because your data is not good enough. But just, we are very aware of the metadata, the data around the data and what we're working with in the beginning of a project. Because a lot of times it's not our data. We don't manage it. We didn't collect the inventory. We don't know the history. So we're just very careful about being honest with the client about what we're working with. And we do a lot of data assessment, just kind of like um, a run through, an assessment of the quality of the data so that we understand what we're working with and try to understand it as well as we can. Um, so yeah, it is challenging. I think we're just careful and transparent about the data that goes into the model.